Curcumin, also known as turmeric, is a plant with significant economic and medicinal value. Beyond its common use as kitchen spice, turmeric plays a crucial role in traditional medicine and scientific research. Indonesia harvested over 205 million kilograms of turmeric in 2023, highlighting its potential as a valuable resource in scientific advancement, particularly in the health sector. One of the key bioactive compounds in turmeric is curcumin, known for its anti-inflammatory, antioxidant, and anti-cancer properties.
Unlike NSAIDs, curcumin offers a safer alternative with fewer side effects. Long-term use of NSAIDs can lead to gastric irritation, increased bleeding risk, and kidney damage, whereas curcumin demonstrates low toxicity and is more compatible with the human body. However, curcumin's potential is hindered by its low bioavailability. Due to its hydrophobic nature, curcumin has poor water solubility, resulting in inefficient absorption by the body. It is also rapidly metabolized and excreted, limiting its therapeutic effectiveness. Its instability in alkaline environments such as the small intestine further reduces its absorption.
To overcome the hindrance, we proudly present to you Curcumex,
Turmeric capsule formulation with microencapsulation technology to enhance curcumin's bioavailability. I'm Diva.
And I'm Kaila, and we are under the guidance of Miss Nadia, and we are from KESATUAN BANGSA School.
In this research, we are focusing to determine the effect of microencapsulation formula in increasing the stability and effectiveness of curcumin in turmeric capsules. Also, knowing how much the increase in curcumin bioavailability resulting from turmeric capsule formulations with microencapsulation technology compared to conventional forms. And last, knowing the physical characteristics of microencapsulation-based capsule formulations.
We begin our experiment by extracting the turmeric by maceration, and after leaving it for 3 days, we filter it using a filter paper and the help of a funnel.
The evaporation was done using ethanol to bring up the active compound, especially curcumin, the main factor contributing to the expected result. To separate the ethanol and the turmeric extract, we used the rotary vacuum evaporator.
The resulting extract then will be analyzed, including of organoleptic tests and characterization tests consisting of A. Determination of moisture content, and B. Quantitative identification of curcumin by UV-vis spectrophotometry.
The main components of our encapsulant are maltodextrin and cassava starch. We use 3 different formulas. The first formula, we use 3% of cassava starch and 1% of maltodextrin. The second formula, we use both 2% for the cassava starch and 2% for the maltodextrin. And for the last formula, we use 1% of cassava starch and 3% of maltodextrin.
Then we made the microcapsules by spray drying. To determine which formula is the most efficient, we evaluated the physical parameters of the microcapsules and in vitro inspection by using calibrated dissolution method.
Coming up to the result, first thing first, we're going to start with the characterization result with the moisture content. The turmeric extract we successfully synthesized has good quality according to the Indonesian Herbal Pharmacopoeia. The extract is thick, yellow-orange in color with a characteristic turmeric aroma and a bitter taste. The moisture content test was conducted by weighing the extract mass before and after drying until a constant weight was achieved. After based on the calculations, the moisture content of our turmeric extract was determined to be 2.3%, which is well below the limit set by the Indonesian Herbal Pharmacopoeia, which is less than 10%. The lower the moisture content in medicinal materials, the lower the risk of microbial and fungal growth, as well as damage caused by insects. Second one is the quantitative identification result of curcumin using UV-vis spectrophotometry. The first step was to determine the optimal wavelength for the standard curcumin solution. For the morphological analysis results of microencapsulation, among all formulas, Formula 3 produced the highest yield from the spray drying process, which was influenced by the amount of maltodextrin it contained. However, as observed from F1 to F3, the color gradually faded, indicating that the lower the starch percentage in the microcapsules, the lower the curcumin content. In F1, the granules appeared round and uniform. However, some granules fused together, and their surfaces were wrinkled. This was likely due to the dominance of cassava starch as a coating agent, which has adhesive properties. In F2, the granules had highly irregular shape and size, with almost all granules merging in one another. F3 resulted in granules that were relatively round and uniform. though some still had wrinkled surfaces. Additionally, the granule size was significantly smaller compared to the other two formulations. The last one, for the bioavailability examination results, curcumin was tested before and after passing through the stomach and intestines. After passing through the stomach, its bioavailability decreased to F1, which is 0.68%, F2 with 1.25%, and F3 with 1.40%. Interestingly, the higher the maltodextrin content, the lower the bioavailability in the stomach. Meanwhile, after reaching the intestines, bioavailability increased as starch content decreased, with F1 having the highest value at 10.1%, followed by F2 at 6.20% and F3 at 4.04%. In conclusion, maltodextrin influences curcumin stability in the stomach, while starch affects its absorption in the intestines. An optimal formulation is crucial to maximize curcumin's effectiveness in the body.
Based on our experimenting, we know that Formula 3 is the most optimal formulation due to its superior bioavailability in gastric condition, reaching to 1.4%. This suggests that Formula 3 exhibits greater stability in gastric condition environment and has higher amount of curcumin compared to other formulations. Although F1 has the highest bioavailability in intestinal condition, the morphological structure of F3 is way more favorable, with particle size 10 micrometers smaller. This smaller particle may contribute to improved solubility and stability, enhancing its overall effectiveness. Therefore, considering both bioavailability and morphological structure, F3 is identified to be the most suitable formulation.
To enhance this research, there are two recommendations that can be done. Firstly, we need to do the stability testing to determine the shelf life of the microcapsules, ensuring the quality remains intact over time. Secondly, further testing needed to be conducted to understand how the stomach and intestine influence the release of the curcumin, allowing its effectiveness in the body to be optimized. With more in-depth research, a more stable and bioavailable curcumin formulation can be used for maximum potential of the curcumin.
Reaching to the end of our presentation, thank you for your time and attention. We hope through this research, turmeric will be used for its maximal potential as well as becoming an alternative for future medicinal world.
See you in another time, everyone.
Bye!